Hello guys. So in this video, we're going to be calculating the change in enthalpy in our reaction. And our reactants are going to be sulfuric acid, H2SO4, and sodium hydroxide, NaOH. And we are also given their molarities for calculating moles. So first of all, if it NaOH is an ionic compound, so we know that we have to write out its cation and anion, which is Na plus NOH minus. H2SO4, not ionic molecular, but it breaks down into SO4 2 minus and H plus. So first of all, we'll write a balanced equation that would give us NaOH aqueous. And we know these are aqueous because molarities are given. Aqueous, it gives us Na2SO4 aqueous plus H2O liquid. So just balancing it out, making sure it's balanced, so it's going to be 2H2O and 2, sorry, 2 NaOH. So this is our balance equation that we can use. Next, we're going to find out the moles. So to find the moles of NaOH and H2SO4, we'll just multiply their molarity with their volume. So for NaOH, it is going to be 0.4 molarity multiplied by 0.150 liters. That gives us 0.06 moles for H2SO4. It is 0.3 molarity multiplied by 0.200 liters. That also gives us 0.06 moles. So it's the same amount of moles. Next, it is, I believe it's not written, but we have to find out the limiting reagent in this question as well. So for the limiting reagent, we can just, because as both of these molarities, as both of the moles are same, so we can use comparison and see which one, rather than having to solve it out. So we can tell that we need 2 moles of NaOH for the production of 1 moles of NaSO4, and we only need 1 mole of H2SO4 for the production of um, Na2SO4. So this tells us that NaOH is the limiting reagent. Again, how we found this out? We needed 2 moles of NaOH to get 1 mole of NaSO4, Na2SO4, while we only needed H2SO4, 1 mole of H2SO4 to get the same product. So that gives us our limiting reagent. So now we are going to calculate Q. First of all, we need to get our total volume. That is going to be 200 ml plus 150 ml. That gives us 350 ml. Next is the mass of the solution. So total mass, assuming that the density is 1 gram per mole as given in the equation. That means it is 350.0 grams. And next, we're going to find out the change in temperature, which is 30.5 minus 22.5. So 30.5 minus 22.5, that gives us 8 degree centigrade. That is our delta T. Now, now we're going to use this formula of mass multiplied by heat capacity multiplied by delta T, which is our Q is going to be 350.0 gram multiplied by 4.18, which is already given in the question, 4.18 joules per uh, gram centigrade. Yeah, multiplied by 8 degrees centigrade, which is our delta T. This, when we solve this out, gives us 11,704 joules. So uh, all of our extra stuff cancels out. So grams and grams cancels out. Let me just do it in a different color so it's a bit more obvious. So grams and grams cut out, C and C, Celsius and Celsius cuts out, only joules is left, and that is what we have here. So this is joules. First, our answer is supposed to be in kilojoules per mole. So we need to convert this over. So we can just do that on the other page. So that gives us 17, sorry, 11,704 divided by 1,000. That gives us our Q, which is going to be 11.704 kilojoules. And now the final calculation we need is delta H per mole. So with that, we do Q over mole of NaOH. That gives us 11.704 over 0.06. So now, actually, what we really want is the delta H, not of NaOH, but of the reaction. And for that, we can just use a mole to mole ratio. So 1 mole of NaOH. So yeah, so it is 2 moles of NaOH per 1 mole of reaction. So that would give us multiplied by 1 to 2 mole ratio. And then we solve this out. And we get 97.533. And we can just round it down. So 97.533, round it. That gives us 97.5 kilojoules per mole. And this is going to be our answer. Going over just what we did, we first of all um, got our valence equation, then we got out our moles, then we found out our limiting reagent through comparison because we had the same like amount of moles, so we can just use comparison rather than solving it out. Then total volume was found, total mass was found, delta T was found. Then we used MC cat or mass multiplied by specific heat capacity multiplied by delta T. We solved that out. We got our joules. Then we converted joules to kilojoules right here. After that, we took out our delta H of NaOH, which is the limiting reagent. We solved that out. Then we also multiplied with the mole to mole ratio because we have to find out the delta H of the reaction and not the not NaOH or the limiting reagent. And our answer is 97.5 kilojoules per mole. Thank you.